Hello everyone, welcome back to the one more session of multimedia systems. So we were discussing about the concept called the optical storage media. Let us recall what we have discussed in the previous session in accordance with the continuation of the next topic. In the previous session we had discussed about the compact disc read-only memory, the features, the specification of compact disc read-only memory, and also the benefits we have seen it, and we have seen how blocks are categorized. What do you mean by blocks? How are they segregated? What is the amount of data that's been stored? And also the pictorial representation of the blocks we have seen. And next, in continuation with the CD-ROM read-only memory, we have seen about the modes. So in CD-ROM read-only memory, we had two modes. One, the CD-ROM mode 1 and CD-ROM mode 2. With the help of a architectural diagram, we had compared and written both the modes, and we have compared with the difference between the modes. So what is the amount of data storage, how the data has been categorized with a total amount of 2352 bytes, how it has been segregated with respect to the storage. Let us continue our discussion. So in the previous session with respect to CD-ROM mode 1, we have seen the various benefits. Now even with the CD-ROM mode 1, we have CD-ROM mode ROM, we have some limitations. What are those limitations? When we talk about the limitation, CDs have high storage capacity and at a constant data transfer rate. This is the important thing that needs to be considered, and the random access time varies with respect to CD-ROM, with respect to a manufacturer and the device specification. This is one key part where we mismatch with respect to the accessing of the data with respect to storage. And we also look into the time it takes between the positioning of the distinct blocks. So based on the positioning, of the distinct block, the CD-ROM has three main limitations. Let us look into the first one, that is the synchronization. First one is called the synchronization time. Why it is the limitations? Now when we talk about the pits and lands, so we know that there is a variation of pits and lands between the storage with respect to our data. So the sequence of pits and land would be there. If it is too much, again if the length of the pit is too much, or if the length of the land is too much, the phase shift, the phase synchronization clock will be very difficult to find it. And again, if the length of pit and land is too short, there would be a continuous phase shift. So again, that synchronization bit to identifying the variation between pits and land would be difficult. So this is the first limitation when we talk about the CD-ROM technology. Second one, we know that CD-ROMs work on this principle. What is that CLV? Constant linear velocity. Means when we talk about the constant linear velocity, it is the rotation. Okay, rotational velocity we are talking about. See, when we talk about the CD, it looks like this, and where the track starts up like this, somewhat in a spherical shape. So when we talk about the rotation at a constant linear velocity, when a CD rotates at a particular velocity, by the time, consider a 2 millisecond. By the 2 millisecond, this portion have been rotated twice, whereas the outer portion might have not covered at a single time also. So there is a difference between the rotational value. So here, since the diameter is very less or the coverage area is very less, at a particular rotation, a complete track might have observed or sensed or visited once, whereas the outermost track might have not at all visited or completed its rotation at least once. So this is one major problem. When we talk about the revolution, So there might be 530 revolution with respect to inner portions. When the inner portion is having a 530 types of revolution, what would be the maximum? Whereas the outer side would have encountered only 200 revolution. Look at the difference between the rotations. Means when you call up revolution, complete turnover, so complete visiting. So inner portion would have at a constant linear velocity might have achieved 530 revolution, whereas the outer region, because it's a surface, coverage surface is a bigger one, it would have visited or covered only 200 revolution. This is again one more drawback. Next, seek time. So this is also an advantage with respect to CD-ROM when compared to the magnetic tapes or other things, because in magnetic tapes or any other storage devices, we are not able to continuously we can play, but we are not able to identify a particular portion and play immediately from that point. If you want to play up, we need to forward or fast forward or play in a fast motion the remaining thing, and then we can sense that particular portion. Whereas in the CD-ROM, compact disc, this is not the case. We can directly point out to the data where we want, because we know the address of the track and sector. This is what it says. In the architecture of a CD, we have seen the header information, where header information stores the block information. So we can directly go to that block. But what is the problem now with the seek time? Because the seek time, when we talk about the seek time frequency, it amounts about almost 100 milliseconds. This is the problem now. Why we call it as 100 milliseconds? Because it takes a lag. Though we may be able to point out at a particular data or particular block or tag, so it is playing, it gets played, but there is a time delay, because the device is seeking particular amount of time in order to go there, fetch the data and play there. So these are said to be the limitations of the CD-ROM technology. So there are a lot of plus points with respect to CD-ROM technology, but in spite of that, these three points are said to be the three main limitations. One is the synchronization time, and second one is the revolution with respect to constant linear velocity, and third one is the seek time. So next, let us look into the extended version. Again, when we talk about the current positioning time in a CD-ROM, so the desired position can also be achieved. Now this seek time, the 100 milliseconds, is also overcome with the latest technology using the cache memory, or we call it as cache memory. Though this was a limitation, this has been overcome now with the latest technology. And again, this limitation is also overcome by speeding up. When it call up a speeding up, now the rotation speed has been increased with respect to 40 times more. So when we talk about constant linear velocity and the rotation speed has been increased more, means we can have more number of revolution, though even obviously the inner portion of the data is much more increased, but the outer region is covered at a very fast phase. So these are the limitations, and the latest technology with the latest one, we are already able to overcome those limitations also. This is about the limitations of the CD-ROM technology. Next, let us look into the one more concept, that is CD-ROM extended architecture. As the name itself suggests, it is also CD-ROM, with respect to some of the things that has been extended with the architecture. So it is also denoted by, in the short, XA. The XA means the extended architecture. What is this CD-ROM extended architecture? This CD-ROM extended architecture is also based on the CD-ROM specifications, okay, except with respect to some minor changes with respect to the architecture. The previous specification what CD-ROM had, the same thing has been carried here with a bit slighter modification. Now, second thing, this was established by NV Philips and Sony Corporation. Even CD-ROM was done by NV Philips and Sony Corporation. But what is the plus point here? With respect to NV Philips and the Sony Corporation, Microsoft was also involved here. So the total idea behind this or the credit goes to all the three, that is NV Philips, Sony Corporation and also Microsoft. The main motivation to have this extended architecture is totally to address the inadequate consideration paid, okay, until the concurrent output of multiple media. Main, I wanted to repeat it again. In short, the main idea or the main intention was to adopt or support multiple media types. Okay, this was the main intention in order to develop the CD-ROM extended architecture. The many features of CD-ROM extended architecture involves the architecture of CD-ROM DI. Along with that, CDI, we call this as CD interactive. Some of the features of CDI was also incorporated in order to CD-ROM extended architecture, because we know that CD-ROM interactive had a very good features with respect to video technology also. That is why this concept was incorporated in this. And next important parameter when you look into the CD-ROM extended architecture is, whereas in the CD-ROM we had two modes, that is mode 1 and mode 2. Here CD-ROM extended architectures uses only CD-ROM mode 2 only. It does not make use of mode 1. In the previous sessions we have seen what is mode 1, mode 2 with respect to CD-ROM. Now CD-ROM extended architecture uses the CD-ROM mode 2 as a primary concept with primary specification. Based on this, the CD-ROM extended architecture has been developed. Let us look into the CD-ROM extended architecture with the help of diagrams. Like that of CD-ROM mode 1 and mode 2, CD-ROM extended architecture also has two types. So where we call it as CD-ROM mode 2 frame 1 or form 1. Second one, CD-ROM mode 2 form 2. So whereas in a CD-ROM mode, I would like to clear it again. In a CD-ROM we had CD-ROM mode 1 and CD-ROM mode 2. Whereas here CD-ROM mode 2 with respect to extended architecture form 1. CD-ROM mode 2 with respect to extended architecture form 2. Let us look into these. This is with respect to CD-ROM mode 2 of form 1. So what I am writing here is CD-ROM mode 2 with respect to form 1. Now what is the first bit? As common, we have synchronization bit. We call it as sync. What is the amount of bytes used? 12 bytes are used. Next is a header. For the header, we have the 4 bytes. So next we have the subheader. For the subheader, we have 8 bits. Next is user data. For user data, we have 2048 bytes of information. Next we have EDC, that is error detection. What is the amount of error detection used with respect to CD-ROM 1? It is same, 4. Next is ECC, error correction, that is 276 bytes. Now out of 2352 bytes of information with respect to CD-ROM mode 2 of form 1, the distribution of bytes are as follows. So here when we look into this form 1 with respect to mode 1, there is no much difference, but only a small difference is there. Whereas subheader was not there in a mode 1, whereas here subheader has been introduced. How did this 8 bits come up? 8 bytes come up. So in a CD-ROM mode 1, we had a blanks of 8 bits. So that blank has been totally reframed into subheader. So rather than leaving it for unused, it has been used as the 8 bits here. So look at this. We have synchronization of 12 bits where it says, so where is the starting position? A 12 bit says what is the information and where is the starting information. And the header says the information about the block, what kind of information is present. And subheader also use the subdivisions, because we are talking here with respect to CD-ROM extended architecture, there might be multiple data forms. When we talk about multiple data forms, it might be audio, it might be a video, or any other computer data might be there. So all those multiple data information can also be stored or held in a subheader forms with respect to this block itself, right? Next, we have 2048 bytes of information or the storage area that is been given to the user. Then we have these four bytes for error detection and 276 bytes for error correction. This is about the CD-ROM mode 1. Now let us look into the next form, that is CD-ROM mode 2 of form 2. Look at this. In both the things, it is mode 2. We are not touching mode 1 in the CD-ROM extended architecture. So now apart from the form 1, we are looking into the form 2. Here what is the thing? Here the whole information is categorized only into 5 divisions. What is that? First one, sync. I don't explain what are the individual, already we have explained it even very clearly with respect to mode 1 and just now. So synchronization bit is 12 bit. Next again we have the header, as usual 4. And also we have subheader, that is 8 bytes. Then what is the next thing? User data. Now here lies the property. What is the amount of user data? We are having 2324 bytes of information. Okay, look at this. Now how did 224 bytes of information is done? Now we have cancelled the error correction rate, because we know that even with respect to CD-ROM mode 1 and mode 2 similar kind of thing was happened, whereas error correction was eradicated, or it was left, or thinking that, or with the practicality there was no much error correction was needed, because CD can get damaged only by two things: one, the physical damage, or with respect to the dust or a scratch. So error correction was not much lived, and again because of the interleave storage property of the data. Next, when we have the one more thing, that is the error detection and correction. Now the error detection and correction was involved in a single block itself, so which had 4 bytes of information. Now out of 2352 bytes of information, this is how the distribution of the data with respect to the CD-ROM mode 2 form 2 happens. So these are the two different modes of CD-ROM extended architecture. This is very important even with respect to the examination point of view. Now with the extended explanation with respect to mode 1, it has improved error detection and correction, because we have more number of bytes there. Yes, the more error detection correction quality has been improved here, and also 4 bytes are needed in order to error correction, and 276 bytes for just correcting the errors. This is a much more storage or much more facility, more with beyond the requirement. Beyond the requirement specification has been achieved here. Like, unlike CD-ROM mode 1, 8 bits of unused data, I wanted to clear it here, look it. Whereas CD-ROM mode 1, this 8 bits was totally pushed after the user data here. So the unused data that was never used was retrieved and used as a header in the CD-ROM mode 2. So this is one important, where you get a maximum of 2048 bytes of storage information. Coming back to CD-ROM extended architecture. So what is this? Here we are able to get 13% more storage area when compared to the mode 1. Means the storage quantity has been increased by 13%. Now by how do you say, look at this area storage user data bytes itself, whereas here in the mode 1, for mode 2 form 1, you are able to get 2048 bytes, whereas here you are able to get 2324 bytes of information. And one more importance here is this, we can be used to store compressed data of various media. That is the plus point. That is yes, here you are able to store 13% more with compared to the form 1, and also compressed data of various media formats are we are able to store in this format. So the idea or intention of having CD-ROM extended architecture was totally fulfilled with respect to CD-ROM mode 2 form 1 and form 2. This is the importance of CD-ROM extended architecture. Now again, when we talk about this part of CD-ROM with respect to CDDA and CD-ROM, the most of the things data consist here are homogeneous data. Okay, when you talk about CD-ROM, that is CDDA and CD-ROM, homogeneous data is only stored, whereas here when you talk about data with respect to storage, compressed data is achieved, whereas there compressed data was there, but retrieving or storage or damage after the damage, retrieving of compressed data was a huge problem, whereas here it is not the case. Why it is not the case here? Because here the data are stored concurrently in an interleaved format, because after one between the another interleave, so a damage or a scratch has occurred. So not complete data is lost, a portion of the data is lost, so that it can be corrected detected or corrected or rectified, and finally it can be retrieved. This is the plus point when we talk about the CD-ROM extended. The interleave storage of retrieval is the main concept that lies behind both the CD-ROM and CD-ROM extended architecture. But this architecture also supports very beautifully the compressed data. So this is the advantage of this. So when we talk about the next concept, the next topic, that is the compressed data of different media. So what is this compressed data? Why are we talking about this? Because CD-ROM extended architecture started supporting the compressed data. So we talk about the compressed data now. So using the interleaving means the storing of interleaving means in between. Interleaving, the CD-ROM extended architecture always allows to store the different media with respect to compression. Means it supposed compressed media formats. This is the plus point. We are not talking about only different media format. It also supports the compressed. This is the importance of compressed data with respect to the media. Then audio can be compressed at the different quality. When we talk about the audio with respect to different quality, so what is this method? We call it as AIPCM. AIPCM stands for Adaptive Differential Pulse Code Modulation. With this Adaptive Differential Pulse Code Modulation. So this method is used to compress the data in the CD-ROM extended architecture. When you talk about the compression, you might say, sir, what is the amount of compression that can be achieved? So what is the percentage, or you should, when you talk about compression quality or quantity, you should have some measurement. In the example, when we talk about the derivation of examples of storing, we had taken the 74 minutes as a maximum time. So when you talk about the 74 minutes of audio, because it was a standard value that we had considered, based on 74 minutes we had derived the storage capacity of a CD-ROM in the previous sessions. Now let us take the 74 minutes, which is a 74 minutes of audio when it is not compressed. When it is compressed, okay, we are able to get or extend this 74 minutes into 19 hours. So this is the uncompressed audio, okay, and this is the compressed audio. Means when we compress the data, we are able to store 19 hours of information, audio information into the CD-ROM extended. This is a huge amount when compared to the uncompressed data. And the one more thing that you might ask is, sir, what about the quality? Obviously, there would be loss of some quality. It is negligible. I'll give you an example. Sir, so when most of you asked me in the previous session, we talk about the compression. So the same thing is compressed. Why do we lose the quality of our information? So I'll answer this question now with an example. Suppose you wanted to travel from one place to another. You have a suitcase, okay, where you carry your luggages. That suitcase is able to store two sets of dress, that is 2 shirts and 2 trousers, okay. So you can sufficiently and very in a good manner, you can fold it and place it. Now you have the third set, that is one more set of dress, that is a shirt and a trouser is there. Now how do you place in that suitcase? This is the question. Now that suitcase accommodates only 2 pairs of dresses. Now you have one more pair of dress. What you do now? What you do is you squeeze those information, that squeeze those dresses. So you squeeze both the pair of dress, means you fold it into as smaller as possible, compress it, okay, and push the third one into it. Now the 3 pairs of dresses is also stored in the suitcase, means now the suitcase is able to accommodate all the 3 dresses in a compressed way. But when you open it, you get wrinkles on it. Okay, notice, means the quality of iron you had did or the quality of the shirt is lost to some extent. It doesn't mean totally it will be shabby kind of thing, but you might find some wrinkles, means there is a loss of some quality. In the similar way, this example can be suited here. When you have the compression, you are able to accommodate more information. That's true. On the other hand, there might be some lower quality of loss or lower quality of the reduction with respect to quality is achieved with respect to the sampling of values. The compression is very much necessary in order to support these things. Next, what are the different possible compressions that been supported? Let us look into that. So different types of compression or variations that is achieved. First we have level B. When we talk about level B, stereo, and also level B, mono. What do you mean by mono and stereo? In the previous sessions, in the beginning and also in the previous session, I have told you stereo is about the 2 channels, okay? Mono is about the only 1 channel. And next is the level C, stereo, and level C, mono. So these are the things. When we talk about the compression rates, okay, the compression factor, here we are able to achieve 4:1 compression with respect to the level B stereo. Here we are able to achieve 8:1. Here also it is 8:1. Whereas in level C mono we are able to achieve 16:1 the compression. Look at the compression. The next parameter we are looking into the sampling frequency. Here it was a compression. Here it is sampling frequency. When we talk about the sampling frequency, here it is 7,800 samples. Means the frequency at which the compression happens is same here also, 37,800 hertz. What about these two? Here it is almost 18,900 hertz. Similar, whether it is mono or stereo, it is 18,900 hertz. So we have seen about the compression and the sampling frequency. Next comes the capacity. So when we talk about the capacity, here in the first one we are able to get the storage capacity of 4 hours 48 minutes. With respect to the level B stereo, whereas in the second one with the mono we have 9 hours 36 minutes. Nine hours 36 minutes. Comparatively, it is much more higher storage capacity because it's a mono, whereas in the B it's a stereo type. It obviously has 2 channels. And next we have 9 hours 36 minutes same. Here also. With respect to the level C stereo. But when we talk about the level C mono, we are able to get 19 hours 12 minutes of the storage capacity. So when we talk about the data rate, what do you mean by data rate? Data rate is the rate at which the information is exchanged between the two medias, or the exchange of information at rate at which information transferred from one place to another. So at the first one we have almost the 43 kilobytes of information, that is 43 KB. Data rate is high. When we compare to the mono, it is 22. But for this, they have not specifically mentioned. But when we talk about the level C mono, we are able to achieve only 11 KB. Look at this, as the storage increases, the data rates decreases. So these are the different variations or variants of compression that can be used. So and the compression factor, we are able to see the sampling factors, frequency, the capacity, and the data rate is been shown. Now, if I wanted to conclude here, so I would like to explain the conclusion. So when we talk about the conclusion, we have discussed the limitations of CD-ROM, because in the previous session we discussed only about the CD-ROM. So in the session we have seen what are the limitations of the CD-ROM. Next, we have spoke about the new concept, that is a CD-ROM extended architecture. We call it as CD-ROM XA. Next, we have seen the two forms of CD-ROM, that is CD-ROM extended architecture mode 2 form 1. Next is the CD-ROM extended architecture mode 2 form 2. With the diagram we have seen how the 2352 bytes of information is been distributed, okay, in particular block. And we have also seen the compression of data with respect to the modes, and also we have seen the various compression variations with respect to the level B stereo, level B mono, level C stereo, and level B mono. These are the information I had wished to share in this session. Thank you.